Building up from the past, early structural engineering. From the earliest times, humans have been driven to build. The need for shelter and protection from the elements was a primary motivator. Early humans sought shelter in caves or built simple huts for protection. These rudimentary structures were the first steps in the long journey of architectural evolution. As civilizations developed, so did the need for larger and more complex structures. The growth of communities and the establishment of cities required more sophisticated building techniques. Temples, palaces, and tombs became symbols of power and religious belief. These grand structures were not only functional but also served as a testament to the ingenuity and skill of early builders. Early builders relied on readily available materials such as wood, mud, and stone. These materials were abundant and easy to work with, allowing for the construction of various types of buildings. They learned through trial and error, developing techniques like post and lintel construction. This method, which involves placing a horizontal beam across two vertical supports, was a fundamental breakthrough in early architecture. The invention of the arch and dome were significant breakthroughs, allowing for larger and more impressive structures. These innovations enabled builders to create spaces that were not only larger but also more stable and durable. These early structures, while simple by today's standards, were feats of engineering for their time. The knowledge and skills developed during this period laid the groundwork for future advancements in architecture and engineering. They laid the foundation for the incredible architectural achievements that would follow. The principles and techniques developed by early builders continue to influence modern architecture, demonstrating the enduring legacy of early structural engineering. Roman monumental architecture. Arches, vaults, and concrete. The ancient Romans were masters of engineering. They revolutionized construction with the use of arches, vaults, and concrete. The arch allowed for larger spans and greater heights than ever before. Vaults, an extension of the arch, created ceilings and roofs. Roman concrete, a mixture of volcanic ash, lime, and aggregate, was incredibly strong and durable. These innovations allowed the Romans to build monumental structures like the Colosseum, the Pantheon, and aqueducts that still stand today. Roman engineering served as a model for centuries to come. Mastering the arch Romanesque architecture. After the fall of the Roman Empire, Europe entered the Middle Ages. During this time, Romanesque architecture emerged, characterized by its use of the Roman arch. The Romanesque period saw the construction of massive churches and monasteries. These buildings featured thick walls, small windows, and heavy round arches. The use of arches allowed for higher ceilings and larger interior spaces. Romanesque architecture reflected the power of the church and the growing wealth of European cities. Reaching for the heavens, Gothic cathedrals and the flying buttress. In the 12th century, a new architectural style emerged: Gothic. Gothic cathedrals were characterized by their soaring heights, pointed arches, and intricate ornamentation. The desire to build taller and lighter structures led to innovative engineering solutions. One of the most important innovations of Gothic architecture was the flying buttress. Flying buttresses are external supports that transfer the weight of the roof and vaults away from the walls. This allowed for thinner walls, larger windows, and the stunning stained glass that characterizes Gothic cathedrals. The science of structure, Renaissance geometry, and perspective. This section delves into the intricate relationship between geometry, perspective, and the architectural marvels of the Renaissance period. The Renaissance marked a renewed interest in classical art and architecture, drawing inspiration from the ancient Greeks and Romans. This era was characterized by a profound transformation in the way buildings were designed and constructed. Renaissance architects and engineers were fascinated by geometry and perspective. They meticulously studied mathematical principles to enhance their designs, ensuring that every structure was not only functional but also aesthetically pleasing. They used these principles to create harmonious and balanced buildings. The symmetry and proportion found in Renaissance architecture were a direct result of their deep understanding of geometric concepts. Filippo Brunelleschi's dome for the Florence Cathedral is a masterpiece of Renaissance engineering. His innovative approach to solving architectural challenges set a new standard for future generations. Brunelleschi used innovative construction techniques and a double-shell design to create the massive dome without the need for centering. This was a groundbreaking achievement that showcased the potential of combining geometry with practical engineering. The Renaissance saw a shift from a trial-and-error approach to engineering to a more scientific and mathematical approach. Engineers began to rely on precise calculations and detailed blueprints, which allowed for more ambitious and reliable constructions. This laid the groundwork for the future of structural engineering. The advancements made during the Renaissance period were not just limited to architecture but also influenced various other fields, including art, science, and mathematics, paving the way for modern engineering practices. The birth of skyscrapers, steel, and the rise of modern architecture. The Industrial Revolution brought about a paradigm shift in structural engineering. The mass production of steel in the 19th century revolutionized building construction. Steel, with its high strength-to-weight ratio, allowed for taller and lighter structures than ever before. The development of the elevator further propelled the rise of skyscrapers. Buildings could now reach unprecedented heights, transforming the urban landscape. The first skyscrapers, like the Home Insurance Building in Chicago, marked a new era in architecture. Concrete revolution, reinforced concrete, and its impact. Another major development during the Industrial Revolution was the invention of reinforced concrete. Reinforced concrete combines the compressive strength of concrete with the tensile strength of steel. This innovative material allowed for the creation of strong and durable structures with a variety of forms. Reinforced concrete was used for bridges, dams, and buildings, and continues to be a widely used building material today. Beyond the horizon 20th and 21st century advancements, the 20th and 21st centuries have witnessed remarkable advancements in structural engineering. New materials like high-strength steel and fiber-reinforced polymers have pushed the boundaries of what is possible. Computer-aided design, or CAD, and sophisticated analysis software enable engineers to design and construct increasingly complex and innovative structures. From the elegant curves of the Sydney Opera House to the record-breaking heights of the Burj Khalifa, modern engineering marvels continue to inspire. Engineering the future, sustainability, and innovation. As we move further into the 21st century, structural engineering faces new challenges and opportunities. Sustainability is paramount, and engineers are constantly seeking innovative ways to reduce the environmental impact of construction. The use of renewable materials, energy-efficient designs, and green building technologies is becoming increasingly common. The future of structural engineering lies in finding creative and sustainable solutions to the world's growing infrastructure needs. A legacy of ingenuity. The evolution of structural engineering is a testament to human ingenuity and our constant desire to build bigger, better, and more sustainably. Over the centuries, we have seen remarkable advancements that have transformed our skylines and the way we live. From the simple post and lintel structures of our ancestors to the soaring skyscrapers and innovative designs of today, the journey has been nothing short of extraordinary. Each structure tells a story of human ambition and the relentless pursuit of excellence. Each era has built upon the knowledge and innovations of the past, creating a rich tapestry of architectural marvels. The techniques and materials have evolved, but the core principles of strength, stability, and aesthetics remain constant. As we look to the future, one thing is certain: structural engineering will continue to play a vital role in shaping the world around us. The challenges of tomorrow will require even more creative and sustainable solutions, pushing the boundaries of what is possible. The quest for innovative and sustainable solutions will drive the next generation of engineers to achieve even greater feats of structural artistry and ingenuity. With advancements in technology and a growing awareness of environmental impact, the future of structural engineering holds endless possibilities. The legacy of ingenuity will continue to inspire and guide us as we build the world of tomorrow.